thought I'd do something fun to demonstrate multi-dimensional list or a two-dimensional list. And so I thought I'd create a tic-tac-toe game. Since it has squares in it, it lends itself well to that idea of rows and columns. And the key to all of this is this two-dimensional list called board. And I have it equal 2 dimensions. The first elements are the top row, and I have 3 spaces. And then I have an element that's the middle row that has 3 spaces. And the bottom row has 3 spaces. And we're going to keep track of whether those contain an X, an O, or a space meaning that square is open. So let's run this game, and then we'll come back and look at the code, just so you can see this run. So I do have a routine here to print the board each time through, and I'm going to use those values to print the board. I'm going to use those values to place an X or an O on the board. So let's play a game of tic-tac-toe. I ask the user to enter an X. And by the way, this is not you against the computer. This is you playing both X and O, or 2 people playing at the computer, specifying X and O and letting the computer simply draw the screen for them. Let's say X does a B2. I take that center square, and you see as I enter a value, the board is redrawn. And so O will do an A1. X's turn again, and we'll do an A3. O counters with a C1. A B1 for X. And let's say O's not really paying attention. They do a C2. And so B sweeps in for the win by doing a B3. And they're told game over, X has won the game. So the program's keeping track of if there's 3 X's in a row or 3 O's in a row. And then asks would you like to play again. I'm going to say yes. We'll say X does an A3 this time. And so O's going to do a B2. And let's say X tries to do a B2 this time. It's already taken by O, and they're told that square is already taken by O. Try again. So it keeps track. If there's a value in any of those elements, it's going to tell us to try again. Okay, so we'll do a B1. C2. C3. A1. A B3 and a C1, and now we're told X won that game going down. Let's have a draw. So now we're told to draw. All squares have been taken with no winner. Would you like to play again? I'm going to say no at this point. There's a sentinel value here, so I type in an N. We're told thanks for playing tic-tac-toe. You all come back now. So let's take a look at our code. So I start with a print statement of let's play a game of tic-tac-toe. I'm going to have a sentinel value called play again, which is going to equal an uppercase Y, and then everything that's going to occur in this loop of while play again equals Y. So as soon as I enter a play again value of something other than an uppercase Y, then we're going to end the game. So we already talked about our two-dimensional board list. I have a variable called next turn, so you can keep track of whose turn is it, X or O. And a Boolean variable called game over, which is set to false. And so when that game over is true, once somebody's won or there's been a draw, we're going to give them an opportunity to play again. The winner is a space right now. And that winner variable will keep track of who won, either an X or an O, and we'll use that in an output statement. And the number of squares occupied. I want to keep track of how many squares have been taken, so if there's 9 squares taken and there's no winner, we know it's a draw. So while not game over, this is going to be our gameplay, and here's where we're printing the board. So we're going to have a row value equals ABC. It's a string variable, but that's going to be used in printing whether the row is A, B, or C. And then I'm going to have a print statement where I'm simply printing the headers for the columns 1, 2, and 3. It looks like I could probably use an extra space there for the 3, so I'm just going to go ahead and add that in. Then I'm printing the line going across, which is just a series of equal characters. And then the root of our printing the board is this for loop. And each time through this loop, we're going to print the 4 lines that comprise row A, row B, row C, and the line below them. So here's the first one. For I is in range 3. So I is going to go from 0 to 2. We're going to print the vertical pipes going across to form the first portion of our row. And then we're going to print with some placeholders. Element 0, which is going to be A, B, or C. So we're going to take row value element I. That's going to come from A, B, C of our row value string. I could use a list here. I could use a list of A, comma B, comma C, all as strings. Strings are basically a little mini list. We can specify each character separately. Then I want board I sub 0. So it's going to start out with I being 0. Element 0 would be our first value of the first element of board. And then placeholder 2 is element I, element 1. That's going to be the second value here. And then the last one, element I, element 2 of board, would be the third one. And initially it's going to print 3 spaces, but as we play the game and we put X's or O's, those are going to be stored here in this board two-dimensional list. Once I've printed that out, then I'm going to print out the remaining vertical pipes, followed by a new line character, and then that closing line of equal signs. So that loop prints out the board with whatever values are being stored in board. The next portion is I'm going to check for win. And I'm going to start checking the rows going across. Notice I said this would be another great use of function, as is printing the board could be a function. We'll get to functions here in a week or two. So I would probably rewrite this at that point and maybe add some functions for you to play against the computer rather than playing both parts, 0 and X. So here's my checking rows across. This is going to be for the top row. I'm going to check if board element 0 equals element 0 equals element 1 equals element 0 equals element 2. That's going to be all 3 elements of that first row, and that first element is not a space. It's either an X or an O, because initially all 3 are going to be spaces, and if I don't do that, then this would be a true statement without the AND portion of that complex Boolean. But if that's all true, we're going to set the winner equal to whatever value is in board element 0. That could be an X, it could be an O. And we'll say game over equals true. I'm kind of a fan of using ternary Booleans. So I rewrote the same thing using ternary Booleans. Winner equals board element 0. If those 3 elements of the first row are all the same and it's not equal to a space. Otherwise it's going to equal winner, which would be just a space. Retain that value. And if that's also true, the same Boolean expression here, I'm going to set game over to true. Otherwise, game over remains false. And then do the same thing for the center row. Here we're using the first elements are element 1s. So board element 1, 0, board sub 1, sub 1, board sub 1, sub 2 are all the same, and board sub 1, sub 0 equals a space, or is not equal a space. We'll set the winner to whatever that value is. And we'll do the same thing for game over. So I do the same thing on the bottom row, just changing the element numbers here to reflect that third element, or element row 2. And then I want to do columns. So here we have 0, 0, 1, 0, 2, 0. That's going to be our left column. And then we have 0, 1, 1, 1, 2, 1. That's our center column. And then we have 0, 2, 1, 2, 2, 2. That's our right column. And then I want to do the diagonal going from the top left to the bottom right. So we have 0, 0, 1, 1, 2, 2. And then the next one, the diagonal going from top right to bottom left, 0, 2, 1, 1, 2, 0. If winner does not equal a space, so we have a value of either X or O in winner, because one of these expressions was true, then we're going to set game over to true, although it already should be true, so I really don't need that. I could comment that out. I'm going to print game over, and then X or O has won the game based on who the value of winner is. And then I'm going to ask them to play again, which I can play again, Y or N, and if they put in a lowercase, we'll convert it to an uppercase. And they could put in anything other than a Y or an N. If they don't put in a Y, then it will end. elif, squares occupied is equal to 9. So this means that there was no winner, but all 9 squares have been taken. That would be a draw. And so here we're going to set game over equal to true. In print, it's a draw. All squares have been taken with no winner. And ask them if they want to play again. Else, this is where we play our game. So I'm going to have a Boolean variable called valid equals false, and while not valid, so while true, we're going to get an input from a square of A1, B2, C3, etc. And we're going to place an X or an O here in that printout based on whose turn it is. And then I'm going to verify to put in a valid entry. I have a variable called row equals D, and I have a variable called column equals 4 down here. And so I'm going to take row and have row equals 0 if square element 0, that's the input. So that first character, if it's an upper A, we'll set it to 0. If it's an upper B, we'll set it to 1. If it's an upper C, we'll set it to 2. And so the 0, 1, 2 reflects the rows of my multi-dimensional list, my two-dimensional list, and which starts counting with 0, and so we'll convert that ABC to 0, 1, 2. Do the same thing with column, again setting column equal to 4, which is an invalid number. And looking at the second character, square element 1, I'm going to check to see if it's a 1, 2, or 3. If it is, we'll set column equal to 0, 1, or 2. And then if row equals D or col equals 4, one of those was invalid, or maybe both of them are invalid, we're going to say that's an invalid entry. So if they put in an X4 or even an X1, it's going to say that's invalid. If they put in a B4 or B5, that's going to say it's invalid. elif, board element row, element column, does not equal a space. The space is already, that square's already been taken. And we'll print that square's already taken by whatever that value is of board element row, element column. Else, we're going to say valid is true, so we're not going to have them re-enter a value. We're going to set board sub row sub column equal to next turn, and then we're going to swap X turn from an X to an O, or vice versa. Just a little ternary statement that does that swap for us. Next turn equals X if next turn is not X, otherwise it equals O. And I'm going to increment squares occupied by 1, so I can check to see if there's a draw. That is the nested loop here inside our else clause that basically allows us to play the game. I would invite you at this point to enter this information. So you can pause here and enter all the way down through the top row. So if you want, you could actually remove this. You don't necessarily need that information because it's duplicated here. So pause and enter everything that's not highlighted. And then I'm going to scroll down. So here's the center row area. You can enter all of that as far as the center row, bottom row, 3 columns, and the diagonal. So pause here and enter that information. And then we'll look at the gameplay. So there now is our gameplay. We'll check to see if there's a winner. We'll check to see if there's a draw. Otherwise, we keep playing the game. And here's our gameplay fork. And when we're all done, we'll say print, thanks for playing. Notice that this comes outside of that while loop, our sentinel while loop. So that's the tic-tac-toe game. Again, I encourage you to enter all this just to get some experience and thinking about the process that one's going through in having this game execute. If you just jumped into this video and haven't seen the prior videos to this, I invite you to check out my Python playlist of videos. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.